My name is Mr. Jason Dietrich. I am a physics and math instructor at Lyon Central High School. I also received a We Are Teachers grant to purchase some robotics equipment through LEGO Corporation. The purpose of applying for the grant was to provide some laboratory equipment for my physics class and to use it to inspire students to study mathematics and science at Lyon Central. Now, the grant itself provided just a part of the funding for this equipment. So this was something that I went into knowing that I'd have to supply some additional funds. Okay, but with the funds that I received, I was able to purchase a Mindstorm's base kit, 9797. Okay, the base kit came with an NXT, I believe it's a 32-bit microcontroller with a lot of different sensors and different plastic parts that you can assemble a variety of different robots. I also purchased a book to use in the classroom. It's called Physics by Design by Barbara Bratzel. And throughout the physics course this year, we will be using this book to look at how to program Mindstorms with LabVIEW software. The students have already demonstrated an interest in the robotics curriculum and equipment that we have here. And one of the first labs is a measurement lab in the physics room or classroom. So what I've asked the students is to understand how a caliper and how a micrometer work, and to use those instruments to precisely measure parts out of the Mindstorm's kit. That's the first thing. And then we also math the different parts from the Mindstorm's kit. So not only is the robotics lab robotics, but it is also used for other labs that I use throughout the year. Okay. I have not at this point been able to purchase the Carnegie Mellon Robotics Academy software, but this is something that I would like to purchase in the near future. Okay. So this is something that I will be doing some fundraising to get. But for now, I've got the Physics by Design curriculum. Okay, so the students are aware that we program using LabVIEW, and then we can download the software into the brick using USB cables. All right. So the students are busy dimensioning, and I have developed, along with some of the students, a demonstration project using the next brick. Okay, so this is our first construction with Mindstorm's robot. I've introduced to all my classes, including my math classes, my teaching assistant. My teaching assistant's name is Matthew Stem. Math is his first name. U is his middle initial, which stands for U as student and understanding. So U and understanding are reference to the middle initial. And the last name STEM refer to science, technology, engineering, and mathematics. So what I tell my students is that if you can understand mathematics, then you can tackle science, technology, and mathematics. Okay, so the objective here is for our TA to provide some inspiration to the students in order to study math and science. The first demo and the first lesson that I'd like to teach our students is that in the math and physics classroom, you have to stay on track in order to succeed. So I've programmed Matthew with a demonstration program. Let me run it. Okay, I've now started the program. It may appear that Matthew is doing nothing at all, just like some of our students in the classroom, but that's not the case. All the time they're learning. All their time they're learning and waiting for input, just like Matthew. Matthew's waiting for me to place my hand in front of this sonic sensor, a distance sensor, and then he will begin tracking along this electrical tape. So let me demonstrate. So he says hello, and then the light sensor measures the difference in light intensity reflected back from the paper and from the tape. The different values of the light intensity make the computer either jog the right or the left wheel or servo motor. And by using that difference in light intensity reflection, he's able to stay on track. So this is the first lesson that my TA wanted to give to the classes and the students in my class, is that in order to be successful in math and science, you have to stay on track. Okay? And then I can stop the program. There's some applause. And he says goodbye to the students. So this is our first introduction to the next Mindstorms robotics in the classroom. I will be periodically updating with new programs and new machines as far as our physics classes are able to construct them. Again, thank you very much for your support, and I appreciate We Are Teachers providing the funding for this technology. Thank you very much.